Next on the panel, I welcome Brian O'Gallagher, who will give us an academic perspective from University Engineering Faculty Cork.
Hi, Francois. So, as you mentioned, my name is Brian Gallachóir. I'm Professor of Energy Engineering in University College Cork in Ireland. I'm also Director of MARI, which is the Science Foundation Ireland Research Centre for Energy, Climate and Marine. And I'm the elected chair of the International Energy Agency Technology Collaboration Programme on Energy Systems Modelling, IEA ETSAP.
Brian, thank you so much for that introduction. Brian, can you explain why the Irish economy through ESB Network implementing the strategy is moving towards a greater increase in distributed renewable energy, and how that plays an important role in the planned carbon neutral future that the Irish government have embarked on? And can you also just explain a little bit more what the impact of wind generation has on our generation mix in the Republic of Ireland?
We have a significant challenge in terms of reducing our greenhouse gas emissions, and energy in terms of electricity, heat and transport represents 2/3 of our greenhouse gas emissions in Ireland. There's key advantages to focusing on electricity as a key starting point for emissions reduction, along with energy efficiency, of course. And in the Irish context, we have very significant wind energy resources. So we've got very high wind speeds. And because of that, we've been developing wind energy over the last 20 years. We now have world-leading levels of wind energy penetration onto our power systems. So we've had a combination of policy support, innovation in terms of engineering, and the engagement with the utility and the transmission system operator in a very positive way, and also societal acceptance of wind energy. So all those have combined to lead us to a situation where now we have over 40% of our electricity on an annual basis coming from wind energy. The other key, I suppose, trend that's happened over the last number of years is the reduction in costs in wind energy and the technology itself. So improvements in the technology internationally have led to significant cost reductions, and we're taking advantage of that. In terms of, as we look ahead, our focus is increasingly on the deployment of offshore wind energy resources. And the key advantage there is that if you've got the wind passing over the ocean, there's much less resistance than when it passes over land. So you get a much higher capture rate of wind energy potential. And if we look at the western seaboard of Ireland, the developments in terms of floating offshore wind in particular are very exciting and a huge opportunity that we can tap into.
Brian, will you please explain how the transmission system and distribution system in Ireland can have to change as we are moving away from fossil fuel generation that are generally centralized towards wind farms that are spread all over the country, where the position of wind farms dictated by wind speeds, etc., is changing, where we are taking our energy from, our off-taking points, and how our electricity consumption will be changing in the coming years as we're moving away from predominantly heating through gas, fossil fuel, towards electricity heating, and the increase in use in electrical vehicles, and how that changes our distribution system, and how that's going to be a challenge for ESB network.
There are both challenges and opportunities associated with that. We have a traditional legacy electricity infrastructure, and our grid infrastructure was designed based on large thermal plants supplying the electricity, and the infrastructure, the design of the infrastructure being used to deliver that electricity that's generated right across the country from where it is generated to where it is required. The challenge of distributed generation, what that brings is it turns that on its head a bit conceptually, in the sense that now we have the electricity infrastructure needing to go to places where the resource is. And in some cases, that's wind farms connecting to the distribution network. In some cases, that's wind farms connecting to the transmission infrastructure. this depends on the scale of the wind farm size. So in terms of the distributed system, this has required us to rethink, redesign, and redevelop and adapt our power system to be able to accommodate that distributed generation. And increasingly, one of the things we're seeing in Dingle is that that's gone down even to a very small scale, as we see homeowners and businesses putting solar panels on their roofs, installing batteries, installing heat pumps. So we've got distributed supply technologies, but also an increase in the usage of electricity as we see a transition away from fossil fuels in areas of transport and heating, which are traditionally delivered directly by fossil fuels. We see that transitioning towards the use of electricity for heating and for transportation through heat pumps and electric vehicles. So the distribution system has to accommodate not only the distributed energy supply, but also increased distributed energy demand. And so it's through innovation projects like on the Dingle Peninsula where we're testing out that in terms of the technology, but also how society engages with the technology. So it's a very exciting time. We're seeing both of those things. And I think maybe to your first question, what we're seeing in terms of the role of prosumers is we can have local balancing. So we can have local supply and demand, and we need to develop the IT systems and the financial and market systems to make that work, as well as the changes in the grid. So the benefits are, though, that we get, as you mentioned, reduced line losses on the distribution system. It also can avoid the need for increased infrastructure expenditure, because if we look at the Dingle Peninsula, for example, that's a rural, isolated part of the grid network. So if we were to add on electric vehicles and heat pumps and significantly add to the electricity load in a traditional sense, we would need to bring in additional power lines. Whereas if we can meet some of that load with locally sourced supply, then that can avoid the need for expenditure on that large infrastructure, on that increased infrastructure. Now, this doesn't mean that we don't still make use of the existing transmission infrastructure that provides still the backbone in Ireland. But I think what it does raise questions for in a new site, in a new location, for example, where there isn't a transmission system, in order to take account of the opportunity arising from both distributed supply and distributed use of electricity.
Brian, thank you so much for putting your time aside to have this discussion with us, and looking forward to talking to you later on during our group session.